Good morning, class, and welcome to our ITDB 101. Today it's Thursday and it's October 15. So this time we have already completed chapter 2, and we have answered some practical questions from scenario, and I have also given you some scenario activity that this will serve as a student-centered learning. And by trying to answer those four scenarios given from the book, and just take a snap, take a picture of it, and then send back to e-learning for recording. I mean, of course, it's a part of the coursework, and it's a part of the student-centered learning. So this time, we'll be about to start chapter 3, and allow me to share my desktop, right? And okay, in our e-learning, I have already provided the link of or the resources of our chapter 3. Actually, this is chapter 3. One second. Let me just label this one as chapter 3. We have already completed the database and database uses of chapter 1. Chapter 2 is data modeling and using entity relationship model. And actually, chapter 3 is also a data modeling. Chapter 3 is also a data modeling, but it would be an enhanced version of chapter 2. So that is the data modeling using enhanced entity relationship diagram. So it's just like a continuation of our chapter 2. And knowing that we have given scenario in chapter 2 just to illustrate or to draw the ER diagram of that given scenario based on how you analyze it. Pretty much also in chapter 3 actually, it comes also with scenario, but there is a little enhancement of performing the ERD we used to work in chapter 2. And with an added E, it became now an enhanced entity relationship diagram. There are some, you will see the difference actually. The diagram is, maybe there are small similarity, but it would be a different kind of approach. But the analysis is pretty much the same, but you will be learning some few things as well so that you will know how to answer a certain scenario if I ask you to do it in EERD. Okay, so without further ado, let's just download this one. I think I have downloaded it already. Yes. Oh, it's already open. Okay. And let's have an introduction about this chapter 3. And at least you have a fairly idea what is chapter 3. We have already knew more on entity, attributes, different type of attributes. So we have also see the identifying the keys like the the identifier, right, for each one of those attributes. And we also come to know the relationship of these entities. And out of those relationship, we also identify that there is also some degree or what we say it was a part of cardinality. If is it minimum and maximum cardinality, and pretty much it's a degree of relationship by knowing it is it one to one to many, and many to many. And we are also get a chance of adding some attribute within the relationship in case that the relationship attributes will be given from the given what do you call this one, from the scenario itself. So this is the summary of our chapter 2, and this time uh, we are still under data modeling, but it will gonna be an enhanced version of that chapter 2, which we called as an enhanced entity relationship diagrams, or in short, it is EERD. In chapter 2, it's only ERD. In your midterm or finals, we will mention there because both scenario can make ERD or EERD. It depends on the instruction that from that given scenario, you have to illustrate it using the EERD. So we will mention there in the question. Maybe another scenario, it should be only in ERD. Okay, so let's see the objectives of our chapter 3. So upon completing this chapter, of course, you should be able to explain the concept of EERD. Okay, you as a student, because soon to be you're going to be developing a database, and pretty much we are still on the stage of analyzing, because we are still working on scenario, identifying the problem, identifying each one of the fields or maybe attributes that we need to put on in every entity. So all of this is still a part of that stage, right? So those analysis phase. And perhaps you might be knowing, thinking why we have this kind of ERD. Why should have we should have only used the other one, which is the ERD? Or should this EERD will be much more better compared to ERD? We will see about this concept and how can we compare this one, of course, physically on the application that you have seen in chapter 2. Because when it comes to ERD, there are some new terms that you will going to learn here, such as inheritance. But when it comes to constraint, at least you have already seen some of the constraints within our ERD, but not much yet, because fully we have to understand these constraints will going to help us to what? To to minimize the duplication, the redundancy, and some error to be entered within your database. So we will discuss this inheritance and constraint within this chapter 3. And of course, at the end of this chapter, similar to chapter 2, we'll be having the practical side of chapter 3, which is now we will going to construct the ERD to represent a given scenario, just like what we did in chapter 2, right? So we have a bunch of examples there. We will have some analysis. We will try to read sentence by sentence, analyze the given scenario. The moment that you complete all the requirements there, maybe one at a time, you are now constructing partial, halfway until you complete your EERD, right? Okay, now this time, let's have an introduction about this EERD. Basically, EERD are specialized ER diagrams. So there are some instances that some information that we wanted to know within a typical ERD won't give us, right? But when it comes to EERD or the enhanced version, is most likely we will get that questions regarding those missing information from a typical ERD. For me, ERD is pretty much almost complete. But then there are also some instances that we will going to get much more kind of suitable for us to start with developing the database, because this is a specialized kind of tool that we can easily understand what's the totality of the system as well, other than showing the flow, like a data flow diagram, something like that. But this one is also specialized of giving much more detail when it comes to inheritance. We will study about that inheritance later a bit. EERD is used for several concepts that are closely related to object programming or object-oriented design and programming. You might heard about OOP. I believe that you have a subject of OOP somewhere in your diploma too. It's object-oriented programming. So which means if you're now performing pretty much an EERD, you are almost close now to codings. You get me, right? Just like you're now writing a code, but then you're not writing syntax at the moment. You're just only illustrating it. So this is pretty much closely to object-oriented programming, because just like I said, we will understand what is this inheritance means. This word inheritance is very important when it comes to OOP. OOP stands for object-oriented programming. or object-oriented design and object-oriented programming. So probably you wait for your course on OOP, object-oriented programming in IT, and you will see what I mean to say. The enhanced ERD are pretty much high-level type of design that will really represent the requirements and the complexity of a certain system or which you are developing at the moment, which is the database. In some cases, yeah, complexity of a typical ERD only is you might only see so many notations there. What are those notations? The entity attributes with the respective relationships, so many. And it seems that it's quite difficult also to identify, or you might miss something there if you really not into more detailed part. So this enhanced version, you won't be miss a thing because there's a high level and there will be later, there will be a low level. Just like hierarchy process, input process output, that you know that there will be a high level until you are going to another sub level or more detailed lower level. Because in ERD, they are all just scattered, right? They're all just scattered. So this would be much more advantage, most likely. That's why this is specialized one and a typical kind of high-level approach that we could apply it by answering those scenarios will be given to us. So even how complex the system or the database will be, it would be much more easy for us to understand because they have constructed it in quite like an organized manner. Not like in ERD, they are just floating around somewhere in your paper, and then whichever entity or attribute you start, that's it. You just put there and connecting those what do you call that one, relationship and so, right? So we will see that one later. What makes this ERD or EERD is or enhanced version is become much more high level model compared to that ERD. What are the features of EERD? So first things we know, we knew already the features of a typical ERD. But what about in the enhanced version model? So basically, it's just like an expanded from ERD. Why? Because we are including still some elements that we allow them to aggregate, generalize, and specialize. Okay, these terms are a bit difficult if you don't know the meaning of aggregate, generalizing, and specializing. I'll just come to think of it. Aggregation is like you're taking some formula, you're taking the sum, you're taking the average, right? You're counting something like that. So, which means that is possible in ERD, not in ERD, but in EERD, because basically it's just an expanded version of these. You won't be getting this kind of feature in chapter 2. You will not be seeing that you are doing some aggregating there. Even the generalizing or specializing specific data, because you won't be seeing your domain values over there. But here we can. In yes, EER, we can do that one by specifying those elements. We will see this one, we will come to know later once that we saw the different parts of the EERD. So that will not be confused. I think some of the students are very good in ERD, some are in EERD, but it's better to know them both, right? Now, what makes help us in this EERD model? It will almost give you a precisions of constraint for each one of the property of attributes actually. This is the time that it's almost likely like you're doing now, you're giving your particular constraint in that attribute. I mean to say is just like you're now creating a database, You're providing now a table, you're doing now the column, you're giving now the data types, the sizes of this, and some constraints of this. This will easy us to apply this constraint, and it's much more precise other than just showing a diagram in ERD without telling what is the constraint between this. Right? It's easy and manageable once that you're going to sit into your computer and start working now with the design, or which means writing now the codes or designing the table itself. So that is one advantage or feature of EERD model. Another one is this diagram will provide you all the elements of ER diagram, but it will be some added feature which is not there in a typical ER. And what are those? Subclasses and superclasses, category or union types, specialization and generalization, just like there in the aggregating in the first point there, and attribute relationship inheritance. It's a complete package. That's why EER is a specialized ER model will help us to identify those detailed constraints. And it's closely, closely related to programming, which is the object programming, object-oriented programming, because you have now subclasses, superclasses. We will study one of these later on the next slides. We're putting them category. We categorize them, or we combine them, such as union types. We even generalize them. We will see all of these added additional features, just like you're seeing in a typical ER. Some few are still there, but majority won't be seeing in ER those added features there. Or we'll say elements, okay? We'll added elements somewhere in your model, particularly in EER. Okay? So subclasses and superclass actually it's an example of programming in C, because C, C++, Java are pretty much can work as an object-oriented programming, right? So which means once that you're developing a typical system, pretty much like you're following this kind of approach, because you're providing them this kind of additional features. Okay, so now probably we can see how it looks first. I'll not be teaching you syntax here because we're not doing programming, but rather at least we name the different hierarchy of typical EERD. This one never happens in chapter 2, because in chapter 2, if I only discuss about entity, you will only see the entity, right? And if we have already discussed the attributes, you can see the attributes connecting along with that rectangular shape along and the oval shape there with their lines. And if we touch now the relationship, we just added a rhombus notation or the diamond shape there, and some other more, until it became a complete one. This one in EER, we have already pattern that we have to follow, right? This is an example of what you're seeing now here on my right side. This is the typical illustration of a EER, but it's not yet precise though, because there are some more details need to fill in on this one. At least you have an idea how makes this generalization and specialization acts as an opposite one to the other. Remember, no? Generalization and specialization is a part of added feature. And it was also mentioned this one in the advantage or the features or advantage of EER compared to ER. So first things first, what is generalization and what is specialization? If we're talking about generalization, basically we are combining the lower level entities into into the higher level entities. Considering that from this diagram, now you're seeing this illustration, right? The bottom part here will be your higher level entities. Oh, and then of course, but obviously, are here are your lower level entities. Basically, you don't see this one in a typical ER diagram, right? We don't mention engineer there, doctor, and professor, right? We just mention as general, particularly like only like high level because they just name as person, something like that. As we define entity is any person, event, right? Location, and many more we can assign on that particular rectangular shape. But generalization is what it means that we combine this one by in such a way that what would be the top-down approach from the higher level to the lower level and the from bottom to up approach, what would be also the relationship for that one. Because by knowing that one, we can easily see that generalization will really give you more detailed information on that particular high level. High level is person, right? And at least we come to know now that you have specific uh, details on it, and those are the low level, which are the engineer, doctor, and professor. But how come this engineer, doctor, professor? What are the relationship, or they do have some relationship between each other? So actually, we call this one as part of specialization. They should be divided into high-level entities into a low-level entities, right? So specialization is dividing these high-level entities into the lower-level entities. Generalization, we combine both, but specialization, we divide them. Actually, there will be another one which will serve as an like an aggregation. Aggregation meaning that you might have approach that you could combine, or maybe they are in the same duties pretty much, or the same thing that they doing, but they are only as one, or just like you're treating them as single one. So or maybe two entities are treated as one, or one will treated as three entities that will be treated as one. We will understand this one later on if we complete those specific generalization, specialization, even including the aggregation for this kind of approach. Now, for now, what we're seeing is just in an introduction, what we're supposed to start working on EER model, right? So this is for the generalization and specialization, right? Considering they have an opposite of each other because one is in the high level and the other one is in the low level. Right. For you to more clear understanding what are these, what we're talking about, assuming it's the same structure here, and let's jump into specialization, right? See, you never do this one basically when it comes to ER, but in EER, we are now implementing those added elements because we add these elements, which is not there in our typical ER diagram. Those engineer, entity, doctor, and professor, right? Those added elements, and considering those are the low level entities, right? We treat them as entities, but they are low level because they are under the hood of the high level, which is the person entity. Okay, let's go specifically what is specialization is all about. Assuming that we are having these domains or values that each one of these records will going to, of course, will should be stored there in your database. If you specialize, if you do specialization, of course, you're giving specific or dividing those under that entities that they might have different functionality. The other one is a much more better example is suppose your high level entity staff, and you divide them, you split them. This is the meaning, no? Specialization divides high level into a low level. That's why this one it became like this. And this is what we had now for this example. We split them or we divide them. And why? Because not all this stuff belongs to each other, or maybe some stuff are all the same when you divide them on that particular scenario. For example, a staff could be an engineer, a staff could be a doctor, a staff could be a clerk, a staff could be a manager, a staff could be a supervisor. So there are so many uh, possible things that might be divided in a typical staff. Or maybe in a school or university college scenario, a staff could be a lecturer like me. A staff could be head of the section for specialization. A staff could be a head of the department. A staff could be, of course, assistant dean, the dean, and so many more, right? So we have many positions floating around in the academic setup database, right? But
Teacher,
this one, yes, dear.
teacher,
Yes,
do you finish attendance?
yes, dear. Don't worry, I will check again later. You want me to mark your attendance,
What? Teacher,
Abdul?
because I have a
Salem?
problem network. Half hour I do open the Teams is not open
Okay, sure, no
because
problem.
the network.
Sure. Yeah, this is recording. You can still see the first discussion we had. No problem. Abdul Salam, I'll just okay, um, mark your attendance. Okay, now you're
Okay.
present. Well done. Anyhow, just like I said, I will still be finalizing the attendance at the end of before the end of the class. Now, this time, what makes sense that the specializations was divided. Literally, if you're now working with the database, who are those people? Who are those specific staff under the engineering maybe, or who are those engineering staff? Who are those doctor who are divided in that particular specialization? And I think this is a good example also for the student, no? If the student is entity, who are the engineering students? Who are the business students? Who are the, what do you call this one? IT students. Or even we can make it much more specialized, just like particularly in specialization. Who are the networking students? Who are the database students? Who are the mechanical engineering students? Who are the finance accounting students? And so, right. So it's very clear that specialization is dividing in the higher entity into a small subpart of lower entity, right? So it's very clear. No, assuming that these engineers, they're listed there, these are the details from their database. Similarly also for the doctor. So it's straightforward, na? At least now you understand what makes this specialization is become a new feature of EERD. This one, you cannot do this one in ERD in chapter 2 because we just until here only. We are only in the high level, which is only entity staff. That's it, right? Remember? We don't even mention the specialized or splitting them into small subpart of entity. We don't do that, right? So only possible in EERD. Oh, EER. Yeah, enhanced entity relationship diagram. Now we know specialization. What about generalization? It's a reverse though. It's a reverse. If we're coming from a more detailed split uh, specialized, they all belong to one entity though. They all belong into one higher level entity, and that is stuff, right? It's like we could just combine them. Again, I'll go to the meaning. Generalization combines lower level entities into as one higher level. So it's very clear. Engineer, doctor, and professor will go bottom up, and they will combine as one. Specialization will go top-down approach because from one entity and it will divide it into small parts of low entity or low level entity or low level sub levels actually that's the correct word to say. So it's just combining them. So which means if you combine them, definitely they will be in a kind of report that they are all together on those raw format. Suppose you have staff from 1 to 49, something like that, and whatever the specialization they have, they will be in one raw, pretty much like a spreadsheet, right? But they came from a kind of split information because you have performed the specialization, so you have identified those low level, which is engineer and doctor. But eventually, if you will see them in the approach of your EER, EERD, they are also belongs to one entity. So it's straightforward. No? Generalization is combining and specialization is dividing. And in short, the the generalization is, I mean, the specialization is from top down to the top to down approach because specialization divides into high level into low level. The generalization is from down or bottom going to up approach. So that's why there's an arrow there, right? So now we understand the generalizations and specialization. This time we have coined out what is this subclass and superclass. Oh, by the way, where did we saw this one? One of the features of ER model, you can see there on the third point, subclasses, and superclasses. Basically, these are added elements that you'll not be seeing this one in a typical ER on chapter 2. And we'll see what makes these subclasses and superclasses will help us understand the EER model. Okay, subclasses and superclasses are basically they are all having entities. Remember that one. And all this entity type, I'm presuming that those entity type will not be mentioned by by either strong or weak at the moment. No, just leave it. Just this would be like an entity type as a rectangular notation. And along with inside that one will be the name on the naming convention of your entity, right? Just like in chapter 2. But some have common attributes and some specific attributes will depend on their kind of work nature. If you will see here, there will be common attribute of engineer. There will be a common attribute of a doctor, correct? Teacher, what are those common attributes? These are the ID, their name, their gender, the field of work, sub, or maybe that you might be seeing also similar to that one, but not quite some which are not common, like expertise. But when it comes to engineering, they don't have expertise. But basically, ID, name, and gender, pretty much all common to them, right? That's why it says here some. They have some common attributes and specific attributes will depending upon their work as well. So which means specific attributes like expertise will not be there in the engineering or engineer because this expertise only depends on their work. Understand? Some are common like ID, name, gender. We can also see that one from the engineer. But some might not be common because that particular attribute is linked to their specific job or work. So this is what this means, this first statement. So all entities in an entity type have some common attributes and some specific attributes will depend upon their work nature. So which means if we have this, we can now apply the concept of supertype and subtype. Basically, this supertype and subtype, like you're having subparts, and you're having like a hierarchy as well, and you're grouping them in such a way they are in all common attributes under those generic entities. And pretty much maybe we can also separate them with an specific attributes under to another new entity, which we'll call a subtype. We will come to see later, just for example, a supertype. If we have all common attribute under a generic entity, we will call that one a supertype. Supertype. That is a supertype. What is a good example for employee in a bank? All of the employee have employee ID, employee name, date of joining, DOJ. Uh, ID, name, DOJ is date of joining. All of them, they have common attributes. We call that one as a supertype entity. They should be under the generic entity, but we call that entity as a supertype. What about if they are not having common attributes? We separate those specific attributes under to a new entity. We will have an example later after this. But what we call now on that part is now a subtype. The other one is supertype because they have all common attributes. They will be there on one specific generic entity. And if those attributes are not common to each one of them, so because it depends on their nature of work, we separate them into a new entity. So what we call that one as a subtype. So giving an example like employee in a bank, they have different teller. That teller could be his job description, right? Or the other one could be a customer support. The other one could be a cashier. The other one, it could be a manager. So they have totally different kind of specific nature of work. So what we call this one are subtypes. Excuse me. 1 second. Okay, sorry for that. 1 second, someone came in. Okay, I hope you understand, but it would not be clearly without showing some pretty much illustration here later, of course. It has to do with the uh, subclass and superclass. So you might be thinking, teacher, the title is subclass and superclass, but you're saying about supertype, and the other one is subtype. So pretty much a supertype is your superclass, because later we'll convert that one, and the subtypes would be like your subclass. And you might be also be wondering later that we will might use this word low level or lower level and higher level. Actually, to tell you frankly, they're all the same. Higher level, lower level is also equivalent to this superclass and subclass. Higher level and lower level is also equivalent to supertype and subtype. So it's just like splitting those generic names though, but basically they're all pretty much the same. But only specifically, of course, if I mention these subclasses and superclass, maybe we will now use specific domain, or I mean values for that one. Okay, to give more further idea what we're talking about, let's have this figure 3.2. Wait, is it my microphone is on? Oh yeah. If you have some questions, don't hesitate to ask, okay? Don't you worry, this is just, again, getting you some ready to this chapter, just like what we had in chapter 2. We have so many series of lesson, and we practice a bit, and we see a lot of illustrations, and some definitions will be there, and some um, of course there will be some key that how you start with working with an ER model. Same as this chapter 3 as well. Right. It would be a bit boring because teacher, where is the application? No, we will not jump directly to that one because it's very important to know first those most specific meaning or information of getting along with EER. Because at the end of this chapter, definitely, we will going to again have a practical side of this, which is by answering the scenario. Okay, going back to this one, is subclass and superclass. So this figure 3.2 is, it seems though it's like pretty much a complete, actually it's pretty much a complete already, but at least you have an idea that the EER looks like this. You might be seeing that we have now the higher level and the lower level, and we have a generalization that this manager, customer support staff, and teller will become as one common entity that would be from bottom to top approach. But if we want to split them, what we call that one, we are specializing them from top to bottom, from your higher level to lower level. But similarly, since we're talking about subtypes and supertypes or subclasses and superclass, and assuming that knowing that each one of these lower level might be having their own specific common attributes, right? It might be a generic. We can just group them in such a way that all those employee under those generic employee emp will be, of course, connected to that upper class. Actually, if we specify the attributes under those specific type of employees, and this is what now we call subclass, or we call that one as subtypes. And what are those? We have attributes that only intended for their nature of work. Teller underscore privilege is only for the teller. Language underscore cert or certificate, that only applicable to the customer support staff. Um, what is this? Manager or MGR credentials. Maybe this is credential. That is only for the manager because they have that position to become a manager. So all of these low level, or pretty much like your subtypes now, are not common to each one of these uh, subclasses because they have only specifically applied them on that particular of their job nature. But when it comes to employee ID, employee name, M underscore name, M underscore join date, M underscore type, they are all common. They are all common. That's why they are under this generic employee, right? They are all under this generic employee. But what we call that one is basically they are now what we called as superclass or supertype. This on the top, but at the bottom here, this teller have its own specific attributes that's only intended for him, and similar to language and manager credentials. And what we call that one, it is a subclass, or in short, subtype. Okay, so at least now you understand this kind of approach. We can apply also what we have learned on specialization, generalization. Now we come to know that we have to know also this subclass and superclass. And we'll see much more specific details because, as I said, this is not yet a fully complete one, though. And this is a good example of much more detailed of a typical EER. Okay, let's see now how can we apply this splitting at the same time, combining at the same time, grouping all those common attributes at the same time, knowing all this subfields or subtype within that particular entity or a sub or lower level entity. Look at this one. The staff is basically our entity, right? And it shows there that it has an attribute which is pretty much common later on to to the subtype of your entities at the lower level, and that those are ID, name, and gender. What you did is you identify this one. Maybe the scenario will said that we have this staff and they are all divided into different specialization or different position like engineer and doctor. So which means the scenario will tell you about that one.
Yes, Mr.
I am sorry. I turned off the microphone. Thank you for reminding me, Ryan. Okay. When was the last time I closed the microphone? Maybe when I stood up, right? Oh, gosh. Thank you. Sorry for that one. Okay, just remind me what time is it, okay? So that I could have, oh, still early though. Let me go back to that particular slide. The previous slide we have seen, it's just like straightforward. We just identify the subclass and superclass. In short, superclass are all these entity and attributes on the top level or higher level, by the way. And the subclass will be here at the bottom. The subclass are here at the bottom. That's it. But only added information why they name as a superclass. Why? Because these attributes that connected to that entity employee, they're all common to all of these subclasses from the lower level, which is the teller, which you have split, remember, split like a dividing specialization. All of these are common. So which means these are all superclass, but the subclass at the bottom here, not all their columns or attribute, just may make it attributes. By the way, these are attributes, are not common. Why? Because it's only intended for their specific job of nature, like a teller. So in short, what we are seeing here, the attributes which are connected to those low-level entities, we call that one as subclass. Right? This language certificate should not be there in the employee. This teller privilege will not be there in the employee on the superclass because it's only specifically on those specialization. I'm sorry because I'm trying to. I should have a water here with me actually. Okay, now moving on to this one is much more specific now. The example is pretty much straightforward. That you can see that this staff has split into specialization, which is engineer and doctor, and those engineer and doctor are considered to be lower class level, right? And from the scenario, probably they have identified that ID, name, and genders are common attributes for each one of these specialization, right? And then from the scenario itself, it was also mentioned that each one of them might have their own specific attributes. That's why see, the doctor only have one attribute, expertise. The engineer will be have only fields and sub attributes. This is only intended for their specific specialization, like the nature of job. So, because we know that these attributes connecting to those low level are considered to be subclass. We don't need to put this expertise in the generic staff entity, right? Because that will be an added column once again. Though it's not common to them, you have to split that one. Similarly also with this, fields and sub. The reason why we are showing this one actually, we are now getting like an idea that these entities might be having relationship to another entities. I'm saying particularly on that particular column only, might be split into like a list of values. In such, we can identify their specialization, or maybe we can make another relationship as considering one entity. This is just like a more equivalent detail of EERD, but I mean, yes, more equivalent detail of EERD. Because if we apply that one in ERD only in chapter 2, we might be adding another morph entities and make a relationship for that. But when it comes to EER, it's straightforward. You might not be seeing the relationship at the moment, but eventually you will understand once that we are now working with tables and relationship, right? It's another example for you guys that just make nothing else of this information. We'll just make shape, okay? I think this one is a generic example. Maybe some of you are still confused at the moment. We don't understand, teacher, the superclass, the subclass. What can you show us another set of examples? Oh, I think this is much more the generic example. It's better for you to really understand. Suppose we're talking about shapes. Shape is considered to be your generic entity here. But knowing that shape has a different type. It could be circle, it could be square, triangle, rhombus, pentagon, and so many, right? We only have given three there. So shape is considered superclass, right? So pretty much he's the parent on that hierarchy level of EER. And what are those split, divided into different small subparts? And those are what we can say now, those are the subclasses. Subclasses, why? Because subclasses of shape. Because definitely this triangle, circle, square are all came from upper class combined together, which is a shape. So which means this is pretty much straightforward and much more easier to understand if we are really talking about superclass and subclass. Because this one, you might be wondering, teacher, it's quite difficult. Where is the superclass? This one, superclass is staff. Subclasses are this engineer and doctor, right? Only makes sense that the subtype are these fields and sub, or those attributes, and the supertype would be all of these of their common attributes. Right? But we're talking about superclass and subclass. At least now you know. That's why I told you in the first place, right? Superclass and subclass is like your higher level and your lower level. Just like what we have started on what is generalization and what is specialization. Okay, it's pretty much the same. This is the most commonly used word whenever students are starting up learning an object-oriented programming. You know why? The moment that you understand what is really inheritance, you can pretty much understand how, if some teacher or some courses will teach you the way how programming of Java will work. Yeah, there will be syntaxes, codes, statements will be there, loops, so many more to learn though. But at the end of the day, they are applying this kind of terminologies. This property of inheritance is very important when it comes to generalization and specialization. I'm not saying that, okay, are we doing the working with syntaxes here or programming? At the moment, of course, no. We only put ourselves that upon learning this kind of technology of programming, object-oriented programming specifically, right? It's either in C++ or Java. We do inheritance. We apply inheritance as well. If you're doing inheritance, what you're doing is you're applying the generalization itself and also specialization. Because these two types had a kind of attribute inheritance which will going to be as a low level entities will inherit the high level entities. Pretty much straightforward. The low level entities, this one, low level entities will inherit the high level entities. Again, the low level entities, which are the engineers and doctor, will inherit the higher level entities. That's inheritance in a different word, like an English word. If you heard about inheritance, of course, or inherit, can I say one thing? Like, you inherit all the properties of your father or your parent when they pass. All the businesses are been given onto you. You inherit all the wealth of your family, and you became the head of the family, pretty much like that. And they have given it up to you. Whatever they have, you have it already. So it's pretty much straightforward inheritance. You inherit physical appearance of your father. Pretty much you have the same height, facial expression, and anything else that would might be compared to your to someone else. You have inherited the intelligence of your brother or your parents. So your parents are quite intelligent, and you also as an intelligent person because you have inherited these from your parents. This is the word English word that quite common. It depends on how you use it. But when it comes to EER, pretty much similar. Whatever this higher level having, definitely all the lower level will going to inherit those. So for just an example, this employee such as employee name, ID, date of job, date of joining, are all inherited by the sub-level types, which are the tellers, customer support staff, cashier, or even the manager. So which means it's very clear. All of this ID, name, and gender of this generic staff entity of the superclass will be definitely inherited by this. One second. Because you might be thinking, these fields and sub and expertise, they don't have, I mean, this engineer and doctor, they don't have ID names and gender as well? No, of course they do have. So whatever this higher level or the upper class level will definitely be inherited by this subtype or sub entities. So it's pretty much straightforward. That's the meaning of inheritance. The attribute of a person who is superclass with such name and age and gender will be definitely inherited by the lower sub-level classes, such as the students and teacher. These are different then. If we have an inheritance or attribute of inheritance, because we only mentioned these attributes, so attributes of inheritance will be inherited by engineer and doctor. The attributes of inheritance of staff will be inherited by the engineer and doctor, which they are all the lower subclass. Other one, is, excuse me about that, relationship inheritance. Relationship inheritance. So we know already what's the purpose of having relationship in ER diagram, right? So in this case now, how can we now work with the relationship inheritance? In a lower level entities, you're gonna be inheriting the relationship of the higher level entities, definitely, because just like what we have shown in the approach of attributes, all the attributes inheritance will be also be inherit from the different low level entities. So what about relationship inheritance? So employee belongs to a department. Example, a certain employee or a typical entity is having a relationship on the department. Therefore, this relationship is also inherited by the lower level subclass. Why? What are those low level subclass in the employee? Teachers, lecturers, HOS, HOD, dean, right? They are all belong to an employee entity, but only might be different is their wins have the different job positions there. But each employee might be a relationship to a certain entity, which is department. So if you remember a review in chapter 2, it could be a degree of relationship or the cardinality. One employee should be in one department, or many employee would be in one department. So one department into many is pretty much like one to many. That's the minimum and maximum cardinality. But we're talking about here relationship inheritance. We are only talking about inheritance, which means if you have already related table or related entity, and what entity is employee having a subclasses, all the subclasses at the bottom will inherit all the higher level, which is the employee is having relationship to the department. So just like from a superclass, we have one-to-one relationship, pretty much like that. It possesses a civil ID number, and all the sub-level will definitely inherit all the relationship from the other entity. We'll see that example later, because for now you are only seeing this quite shallow. But suppose this staff, there's a relationship to another entity which is department. Okay, that can be possible also within our, what do you call this one? Our EER. So we will be having also relationship or relationship inheritance if we have relationship notation over here. Maybe staff, you will use the relationship symbol notation, diamond shape, in one entity there. Or maybe that entity, again, there's a set of subclasses. So we can see that one is becoming bigger and bigger. To continue on that one, it's most likely you've been almost overwhelmed with the terminologies, because let's just have a review. We just start up what is EERD. We come to know what is specialization, what is generalization. Specialization, we just divided into such two lower level, or yes, lower level. But when it comes to generalization, that split into lower level will combine in one entity, which is a superclass. That is generalization. Now, since we're talking about superclass, I mean higher level and lower level, we identify that one, that considering those are also the superclass in the higher level and then the lower level. By the way, we are talking about this diagram, that one, right? Assuming this is what we are talking about. This example of pattern of our EER model. So since we identify the superclass and subclass, which means there are some common attributes on the superclass, which is they call themselves as generic entity, which these are also common to the other subclasses at the bottom, which is good examples are ID, name, date of joining, if we have employee as the higher level entity. Similarly, in the subclasses, those low-level entities there are basically, they have specific attributes which not common to each one of those specialization. So we call that one a subclass. By giving this example, it's very clear, and even with this one, and pretty much only for a very generic example using shape. We added another term, which is inheritance. Actually, inheritance is pretty much almost the same what I am showing to you with the subclass and superclass. Only we apply the word inheritance because whatever the upper class has, it will gonna be inherited by the lower class. Or whatever the higher level entities has, it will be all be inherited by the lower level entity at the bottom. But we define this by specifically two types. One is attribute inheritance. It's almost the same with this, by the way. It's almost the same with subclass and superclass. Whatever the entities, I mean the attributes given on the upper class or the superclass are common to each one of these subclass, so which is what we call that one as attributes inheritance. right? All the lower level entities will going to inherit all the attributes which is belong on the upper class, all right? So which means we call that one as attribute inheritance. This one we're not seeing yet, the relationship inheritance, but in case that we have a relationship from the upper class, all the subclasses there will definitely will be also be inheriting that relationship from the other entity. So we call that one as relationship and inheritance. For now, we don't have any example yet, but I believe that this one is an example in our chapter 2, civil card possesses one civil ID, if you remember, right? One second. Let me compare now. Let me compare now the chapter 2 about this constraint on ERD, or maybe the almost nearly totality of your chapter 2. Let me just open one slide there in chapter 2, and maybe one complete ER diagram though. Do I have a complete ER diagram here, or maybe it's in the book? Um, they are all more detailed though. Or maybe this one. Yes, this one. Example, this one. Okay, it's a scenario, of course. It comes with a scenario. But we are only dealing with this. In chapter 2, actually, if we will compare what we have seen now on the structure of EE or enhanced version, it's totally, we don't see the specialization here. Maybe the relationship, yes, of course, it's there. The attributes are there. But how can I know that I have a difference specialized in the employee? It's not showing here. That's why purely just ERD is like this. Especially now, if we are now dealing with this constraint. Constraint is definitely it's not there in the ERD. What means to say that we can apply constraint also in this model, but only possible and enhanced. And we can identify this constraint by just seeing this one actually. You see that letter D here inside this small circle? Actually, that is a constraint, right? So we haven't touched that part yet though, but it's about time for now to know what is that circle there. That is a constraint. And what does this constraint do? We know already that we have given information on chapter 1. And by knowing constraint is at least we might be limiting or avoiding some discrepancy on your data. So maybe some duplications will be there, right? So accuracy of your data will be most likely having a problem if you don't have constraint. But we separated this constraint. Basically, it's only applicable to the subclasses because they are the member of this higher or upper class. We divide them into two types of constraint, which is the other one is disjoint subclasses, which is symbolizes letter D, and the other one is overlapping subclasses. Overlapping. So which means these two might give us an idea now really how we could apply constraint in your EERD. To tell you frankly, constraint before without this enhance, students only learn the constraint specifically now if they're now creating the table. Example of the constraint basically, it's they will make a primary key or identifier key on that particular table and selecting that specific column or attributes needs to be applied as a primary key. Another constraint my students in ITDB 202 who are working with SQL, they will put their constraint that not null. So which means that particular attribute or column will not be accepting a null one. It won't accept null, but rather you have to enter information there. And so many more. Constraint is like that. You're putting some rules within that particular field or column. Right. When it comes to EERD, we can also show that one in kind of a symbol or a node that symbolizes that if you have a D, you have a disjoint subclasses. And the other one is overlapping. And what are these two different EERD constraints? The first one, the disjoint subclasses is basically if an entity or a certain entity or instance of a super type on the upper level or super class level though belong to one subclasses of specialization, then it cannot belong to another subclass of the same specialization. What I mean to say is, even though that you have a subclasses there, subclasses in the lower level of, or maybe what we call split or divide, which we call that one as specialization. If they don't belong to one subclass, then it cannot belong to another subclass. So which means a good example of this is maybe the engineers and the doctors there is totally different from each other, correct? They are totally different from each other. What the engineer will do is only engineering stuff. Hopefully you understand that one. What the doctor can do is only doctor can do, or based on his or her specialization. The question is, what if the doctor is not available in the company? Do you think the engineer can substitute the doctor and do the task of a certain doctor? I don't think so. Or vice versa. Suppose the doctor is somewhere there in the company and the absence of an engineer wasn't there. So which means the doctor can replace him? I don't think so as well. This is a good example of constraints using a disjoint subclasses. So supertype belongs to one subclasses of specialization only. They cannot belong to each other because the subclasses have, of course, totally different specialization. But the other one can be possible. Maybe this will be possible somewhere in your scenario that overlapping subclasses might share their specialization, something like that. Sometimes the entity from the top or the superclass, you have more than one subclasses at the same time at the bottom in the lower class, which you're split, divided into specialization. And one of the subclass might overlap each one other. We haven't seen any example yet like that, but definitely majority of my examples are all disjoint. I hope you understand me. You see D, disjoint. Just like my example, the absence of engineer, the doctor could not replace him just to perform the engineering stuff or things though. Vice versa, the absence of a doctor, do you think the engineer will replace him and he will do all those doctor job tasks? Of course not. That's why you're seeing D there. This is a disjoint. I haven't shown you some overlap yet. This is also D. See, oh, there's a disjoint there inside that small circle, right? But in some cases, maybe the scenario will tell you that some of the specialization can perform each other. And that is what we call overclass or overlapping class or subclasses. So we might be having O notation there on that node. Let's have this one. Actually, I have already mentioned this, right? No stuff common between the engineers and doctors, hence they are all disjoint. But then, suppose here, Ahmed, Sarah, okay, these are the staff, by the way. And it was mentioned, it wasn't seen here who are those engineers and doctors. Basically, there are no common between these engineers and doctors. But here at the bottom, suppose we have a 6 staff. Uh, it was highlighted there. Maybe the Abdullah and Fatima are belongs to this kind of field of engineers. And you might be thinking, why always there? It's an overlapping. But basically, this is wrong. Why? Because they could not share, they could not combine the subclasses of specialization of a typical engineer and doctor. That's why this kind of example here is totally wrong. But the correct here is most likely the D, right? Because otherwise, if we have some other job that maybe take over by another job description, so maybe that would be it. We can do some overlapping, or maybe otherwise we can do in a different scenario using cooking, right? We will see some other examples anyhow. We have this a good example that this indicates a disjoint. Okay, see now, what we have learned in chapter 2, they're all combined now. This name is a composite one because they are all subparts of those attributes. First name, middle name, and last name. Okay, SSN is a simple attribute that identifier, and the rest would be a simple attributes. But the most important, these are all inherited attributes, inheritance of these lower type subclasses, and they have also gonna be inheriting if in case they have another relationship inheritance here. But we don't have relationship inheritance here in the employee at the moment on the higher level, huh? Now the most important here is the constraint. We're talking about constraint. We have identified the specialization. We have identified that those attributes from the upper class will be common to all of these specific specialization of subclass. Secretary, technician, and engineer has all of these: name, SSN, birth date, address, job type. Right? But subclasses have specific attributes that only belongs to their specific job description, most likely, or nature of work. Like typing speed is only for secretary, technician is technician grade, and engineer is engineering type. So that D basically indicates with that node that the specialization D stands for disjoint. So, which means that totally the technician could not be performing as a secretary and the engineer. But you know what, to tell you frankly, this sometimes never happens in the real world. There are some technicians can be a secretary at the moment now, but the secretary could not be a technician. You get me? The secretary could not be a technician. The secretary could not be an engineer if he or she is just what do you call this one, certified only as a secretary. But to tell you one thing, technician and engineer can be a secretary. You get my point? So some of the specialization might be overlap, and some of which might not be overlapping or separate. Because to tell you frankly, say in this university, in this college, there are some technicians which they have put in a position as a secretary. There are some teachers, lecturer itself, they become the secretary of the HOD, right? Just like an example for this. But if you are certified secretary only, of course, you're not an certified technician as well. You're not an engineer. A certain typical secretary could not be a technician to fix something there, or similarly as an engineer. But to tell you frankly, technician and engineer can be a secretary. It depends on the availability of their own assignments in a particular job scenario, right? Though, from this example, this all indicates disjoint, right? That's why it depends on the scenario. It depends on the company. Probably this example say that they don't have this kind of overlapping, right? But to tell you frankly, they can be overlapped, just like I said. Let's see some example of overlapping. Maybe this would be my last one now, or maybe I'll just stop over here because it's almost 9:38. Now, we just start off with the disjoint. We haven't completed it yet because you saw that there are some lines showing over here, like double line there, and when with the curve there sometimes, one of the example of EER I have shown you there. So there's also significant information why we have double line and single line. So just for now, we just only tackle some few of those of EER model, so that at least by the end of this chapter, we will try to answer one of the scenario and how to put them in EER model. Okay, so just remind me, we just stop on the disjoint, right? We just only stop on the disjoint because, of course, taking consideration on the overlapping is depends on the scenario. To tell you frankly, okay. So I might oppose this. I might uh, not use this kind of disjoint because maybe there might be having some overlapping on those different specialized subclasses there. But as I said, maybe it depends on the scenario, right? Okay, so hopefully you understand fairly on this chapter because this chapter, just like I said, is just only what we call that one. It's just only an extension actually or expanded version of our chapter 2. We just make it much more better and more clearer when it comes to illustration of our ERD. So that would be an enhanced version, and of course. So most likely you might be thinking, teacher, this will gonna be included from our midterm. Yes, indeed. So this is one part of, most likely a part of the long answer question there, by giving different scenarios, and of course the multiple choice questions will definitely be there because we have a lot of terms that we learn from chapter 1 until to which chapter will be ending. Okay, yes to full. I will check now the attendance. Okay, because teacher Hansel is talking too much though. Okay, just let me just go on directly to our CIMS, and I believe that I hopefully you are maintaining a good attendance at the moment, right? Because you might be having, I'm running some percentage of absences here at the moment, probably some of which you have already reached first warning or through email through your advisor. So please limit those absences so that you won't be able some problem, because they won't be allowing you to give sick leave if you reach third warning, 30%. So please avoid that one. Okay, please help me if in case I won't be seeing your name. Let's start with Abdul Salam Abdullah. Okay, present. Abdullah Masood. Okay, present. Abdullah Turki. Okay, present. Al Harit. Okay, one sec. Al Harit is, he was in the morning. No, sorry. I have to check also, maybe in case you might be having some technical issue though. Yeah, he's also not there in before the class starts. So absent. Al Hussein Ahmed. Al Hussein. Okay. Also absent, I believe. Yes. He's also absent. I will going to mark Al Hussein absent. Al Mahanad present.
Yes.
Yes, thank you, Mahanad. Amar Salim. Amar Salim. Okay, Amar Salim, I think, is not also there before the class starts. Okay. Asala Adil, mm, also not there at the moment, but she was there in the morning. Okay, let me just skip this one for a while. Basel, Basel, I got 12 this time. I think Basel was also absent. Okay, even before the class starts. Okay, what about Bashar? I think also Bashar was there. Most likely, please let me know next time why you're um, getting out from the channel so that I won't be marking you absent. But for now, I'll keep this one. Okay, Hadel, present. Jamila, Jamila, let's see, Jamila. Yes, present. Okay, let me hold this one first. Mazin, Mazin, Mazin. We will go there, Ryan, in the scenario because everything we need to understand first, all those theory behind it, and once that we complete chapter 3, we will still go back to chapter 2 and we'll do a lot of scenario there, right? Most likely, especially now you're going to have two sets of different scenarios, right? So the moment that we have completed that one, we will also even go back to chapter 2 so that both scenario you know how to apply it. Okay, don't you worry. This time is so many information are giving you at the moment. But at the end of the day, it's still the practical side. Definitely, it's there. Yes, indeed. You need more practice on that. Where am I now? Hadel is there. Jamila. Okay. Masin. Muhammad Nasser. Muhammad Nasser. Okay. Muhammad Nasser Jadad is absent till now. Okay. Almost 20% now. Muhammad Saeed Muhammad is not there. But let's see. He's also absent. Muhammad Saeed Al-Shanfari, also absent. Muna, I think I marked Muna. Oh, okay, she's also absent. And okay, Mariam, present. Osama, I think Osama is not there also. Early morning. Osama is absent. Ryan, okay, present. Safia, present. The full Badar, present. The full Saeed, okay, present. Okay, I will present the full Said, I think, on my Excel. Right. Okay, Wafa. Okay, and sign up. I think only Wafa was there also in the morning. All right. So there you go. So thank you very much for attending and happy weekend to all of you guys. And we'll see you by next meeting once again. Definitely I want to complete all this theory behind EER so that we could jump directly away from knowing the scenarios itself. Okay, if you have doubts on the scenario on chapter 2, we will work on that. Have a nice day and happy weekend to you guys. Bye bye for now. You can leave now the channel.